And welcome to Daily Space Weather. I think I'm going to do the channel and the show as slowly as is humanly possible today, which just may happen to be blazingly fast. So I have a tendency to do that, do everything as slowly as possible when it is not in a bike race. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Sometimes the slowest I can go is really fast. Anyway, there you can see a massive filament eruption or two or three happening. At least two. There's a close-up of it. And we shall cut to that in a moment, but we've got to keep things moving tonight and keep it a little short because we are running a little bit late. So there's the path. That's today. That's March 14th in 131 angstroms. We did have one M-class flare out of that sunspot 3599. There still is a very high likelihood of large solar flares. Now, of course, we can't see if the sunspot's degraded or not, but nonetheless. So, talking about earthquakes and volcanoes next. Volcanoes is first. And check it out. The Reconnaissance Ridge, the Reconnaissance Peninsula continues to inflate. So, just like you don't want to be the bridge between Earth and space that makes a meteor into a meteorite, you know, you don't want to be hit by a meteorite, you don't want to be the bridge between the subterranean regions and the terranean regions. You don't want to become the bridge that makes magma into lava. Well, that can happen at any point on the Reconnaissance Peninsula. Magma could become lava, meaning it ends up at the surface. Speaking of which, Urta Ale there's a photograph of Urta Ale. Anyway, to continue on, Ibu, Merapi, Popocatépetl, Santiaguido, Fuego, Revenador, Sabancaya, and again, Urta Ale, which is typically an effusive eruption. Past 90 days of earthquakes included a couple 6 magnitude, or at least one 6 magnitude quake, right in the smack dab in the middle of the Atlantic Ocean. So that's always interesting. Check it out. There is that 6 magnitude quake right in the center of the Atlantic, right on the mid-Atlantic ridge there. There's a zoomed out view of that. And let's see how often quakes happen in that area. It is actually somewhat common. For quakes, they are usually to the northeast of there. So, and that's been pretty recent there, still showing up red on our one-day map. So anyway, let's see. These are the quakes of a 5 and greater magnitude. Montenegro had a 5.4. Looks like it may have caused some damage, according to the pager. Japan had a 5.6. Northern Mid-Atlantic Ridge had a foreshock. And then right in the very similar location, a 6.0 magnitude quake. Hopefully that's not a foreshock, as that could be a huge quake. And let us know in the comments if you think the Atlantic Ocean can have a tsunami. Continuing right along, we're going to get back to that data. First, let's cut back to some more solar imagery, shall we? We shall. So again, there's that filament eruption. Great zoom in of that. And and what the heck is, how dare you? Alrighty, that's better. Here we've added the 193 angstroms running difference imagery. And of course, we don't edit the videos to get them onto your screen as quickly as possible. We, quote, keep it raw to pay some homage to the Wu-Tang Clan. So there's 193 angstroms running difference imagery along with 304 angstroms to better accentuate that filament eruption. Also a great example of a Hyder flare. That brightening in the lower corona that you see at the end of that is the Hyder flare. So some plasma blasted off and some plasma splashed back down. So we'll show you some more imagery of that also here momentarily. First, some stats. The 10.7 centimeter radio flux, I think it came down again. Sunspot number dipped 127, so it dropped by 1 solar flux unit, 127. SFU is the radio flux. No geomagnetic storms forecasted by NOAA. The past 4 hours of Earth's magnetic moment from space are next. There's our geospace magnetosphere movie, and things are calm. We see a relatively diffuse and relatively slow solar wind. So no real space weather afoot at the moment, and no major space weather on the way. Earth magnetic moment from ground is next. It's our ground magnetic perturbations map. And yeah, also the last 4 hours, pretty uneventful. So if you're looking for reasons to hide in your bunker or to forecast the apocalypse, now's probably a bad time for your credibility to do that. KP index is 1.67. Don't believe me? Oh, there it is. 1.67 is the KP index. And solar wind, like I said, it's slow and diffuse. Only about 6.5 protons per cubic centimeter according to the ACE. Oh, that's still the Discover. Hang on. Here's the ACE. What's up with that? Could have sworn I selected the ACE. That was ass. All right. Very diffuse there at the ACE. Less than half a proton per cubic centimeter. 0.36. At the Discover, about 7 protons per cubic centimeter at a higher speed. They're 448 kilometers per second. So that looks like a little bit more reliable data to me. Besides that, uneventful. There are our GOES magnetometer readings. They're located at like 23,500 miles of altitude, folks, in the outer Van Allen belt. The outer portion of it, in fact. They are geosynchronous near equatorial orbits. Next, our solar magnetism. There's the view from the top of magnetic sectors. Earth is still in a North Pole sector. Here's our view from the line of sight perspective. Solar B field in blue. Here's our coronal hole line of sight perspective. North Pole coronal holes in green. So that's what's going on. And sunspots are kind of low here. So a little dip in sunspot number. We've seen degradation since yesterday. So there it is. It's, what do you got? 70 sunspots, 69 sunspots. No, seriously, sunspots. 69. That's how many of them there are. All right. So, let's see. We had one in the northeast last night. We'll take a look at the end of the space weather video to see if that's still there. And don't forget to press the like button. And if you're new to the channel, press subscribe, lest thy soul be cast into an ever-deepening and darkening abyss of dim-witted doo-doo diarrhea and teleporting turds. That's not what you want, so press like. The ghost proton flux is flatline. We ain't got no spikes, no solar energetic particle events. X-ray flux is looking pretty low here. We did have an M-class event. It was at about 606. Oh my God, it was at 606. And watch out, folks, because all numbers are spooky. Ooh, 606. Oh, noes. Time to stock up on canned peas for the bunker, folks. Oh, dear God, not 606. Anyway, let me just cut back to this for a minute. We'll take a look at that real quick. 606, eh? I'll find you. I'll find you, solar flare. There it is. At 606. Let's do the super slow. There it is. Oh, yowzers. Yeah, 131 angstroms. It's good times. All right, continuing right along here. And where were we? We weren't there. We were way behind there. Dear God, what is happening? Oh, noes. We've had a train wreck, folks. Yeah, I forgot what tab I was on. I apologize. So we've got sunspots, right? That's a thing. So there's a sunspot scenario. And we may see sunspot number continue to dip here. If you're concerned about that, seek psychiatric help. Sunspot number varies massively throughout the cycle. As you'll see right in here. Where was that slide again? There it is. See the way the sunspot number is like looking like a cardiac arrest here? Well, That's a normal thing for sunspot number, especially around solar maximum. You'll continue to notice an upward trend, most likely, for the next about 6 to 7 months, expecting solar maximum in something like October. And don't forget to press like, otherwise there will be repercussions. We'll have less likes, and we can't have that. So, star charts next. That's what's going on overhead. Cheers. That's what's happening over Lehigh Valley. Wait, let me press now. There we go. Skyandtelescope.org is where to get your own star chart. If you want one, feel free. Here's your solar system forecast. People want to know where stuff is, so we show them. Here's where things will be in 1 week, and if you think planets are causing, like, think planets that are causing your migraines, or if you think planets are causing you to drink too much or suck at your job, planets are definitely not causing you to suck at your job or drink too much. That would be the viewer. The viewer. So don't suck at your job and press like. All right, anyway, next is our astronomy photo of the day, and it's some kind of math nerd stuff. It's like what phase of the moon is 3.14 radians, which means 180 degrees, so full moon is 180 degrees, so that's what it means. It's a pi joke because it's 314, and I'm over that. That's barely astronomy. And here's our coronagraphs, and yeah, there you go. It's limited frames for some reason. Here are some more coronagraphs, and here are even some more coronagraphs. So it does look like a proton event kind of happened there at the LASCO C3, but it was pretty minor. So I'm going to let those play through for you here. Just bear with me. There we go. And let's all watch that together. Ooh. Ah. Ooh. Now, of course, the main feature of these videos is the solar imagery. Of course. People want to see the solar imagery, and it's, it can be a bit of a challenge gathering it all together and showing such massive amounts of it every day and so on. So I don't blame you if you don't want to do it. It is a massive amount of work. Here's stereo A and its difference imagery. And yeah, so some spectacular CMEs, but it's best going to be portrayed by our custom videos. And so there's stereo A and its difference imagery. And let's switch to a different scenario. And how dare you, SNN logo? Stay. That's better. And that's better too. Yeah, all right. So here come our custom coronagraphs, and I would remind you that it is pretty spectacular. So of course it'll all look better when it's all synchronized, right? So there you go. There's your LASCO C2, 304 angstroms and 193. There's the first level of zoom out. Remember, folks, we still see massive plasma instability down there in the southwestern limb, which would be the lower right of the closest star from this perspective. Here's another step out. So just a great view of that massive filament. And I don't think that has an earthly directed component, folks. Now the previous one also not. So I don't think either of those have earthly directed components. If you look at the way this one pops off, it looks like it's largely on the far side. Right there. Nothing resembling a halo from either of those. It's very far to the east. This one up here looks like it's really concentrated when it leaves, and it's very far to the north. So I don't think those have earthly directed components. That's my story, and prove me wrong. As our record of forecasting CME impacts has been kind of stellar. Of course, that's not really even the specialty. The specialty is determining which ones are directed toward Earth. And of course, the ability to forecast them before they happen sometimes. So that was a weird skill that I didn't really want. Oh, yeah. So, yeah, we'll zoom back in here briefly just to show you the filaments in detail once again, as it is time to close out this space weather section. So let's cut back to filaments. So filaments, wherefore art thou, filaments? Because of magnetic fields, suspending them above the sun's massive gravitation. So that's why you see those dark absorption features there. That's stuff in addition to the hydrogen, blocking our view of the hydrogen. That's why they appear as dark absorption features. That is hydrogen alpha, a specific wavelength. It's, 62.8 angstroms. And look at the number of filaments on the Earth side of the disk. We could see half a dozen Earth-directed CMEs just at any moment, give or take. Remember, folks, you don't need to see solar flares or even sunspots for coronal mass ejections. And now's a great time to demonstrate that, because the likelihood of CMEs between today and tomorrow is just about 100%. The likelihood of them being earthly directed is very high, because look where they're located. Let me bring it to the last image here. So look at all these filaments on the Earth side of the disk. That is bonkers. Oh, let me cut to full screen. Shall I? I shall. So look at this. 1, 2, 3, 4, 5, 6, 7, 8. At least 8 filaments pointed right at the Earth. I mean, these are all clearly in an Earth strikeable orientation at the moment. So that is a major CME thing going on right there. And yeah, is it bunker worthy? Nope. Is it going to kill you or destroy civilization in any way? Nope. Will it make some auroral imagery available? Hopefully. We're hoping for some aurora at mid-latitudes. It's fantastic. It's fantastic and not spooky in the slightest. Anyway, here are the last couple of hours from the GOES, is it the GOES 18, I think? The GOES 18, 304 angstroms wavelength. And of course, we stream that all day to the Twitch channel if you want to check that out. It goes to the smashomash.com/smashteam site. smashomash.com/smashteam for subscription services. It's been retooled massively, and Smash staff has been making some berserk changes. It's turning into an SEO masterpiece, folks. So anyway, next is the bonus features segments. Bonus features, charging hazards. We ain't got none. Goes electron flux. It's in a normal range. There's the 1-year graph. There's the forecast model. NOAA expecting fairly flat and modest levels of electron flux. Here's the vibrational frequency where they're measured. The F layer of the ionosphere. The F layer, it shakes around, okay? It shakes. It be shaken. And as it's shaken, it emits radiation, which is detected. It shakes more here and it gets all excited because of the sunlight. But on the night side, it shakes less. And of course, it is decreasingly ionized as you drop down. So the F layer is more ionized than the E layer is more ionized than the D layer. But all of that material is primarily ionized. And that's literally the border between Earth weather and space weather. Okay? So for example, Schumann resonances, they bounce around in between the D layer and the lithosphere. That makes them Earth weather. Outside, everything outside the D layer, this is space weather. From there, all the way to the sun's surface. You see that? That's space weather. Everything below that is Earth weather or something. I mean, of course, actual weather only occurs in the troposphere. But the point is, anything inside the D layer of the ionosphere is Earth weather. It's just a fact, because the material's ionized in space, and it's mostly not ionized on Earth. So, and by the way, when somebody's talking about space stuff and they say plasma, 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 like it's magic, there's a lot of plasma floating around, all right? Material only has to be like 10, 12 to 20% ionized to be considered plasma in space. So anyway, but I digress. Here's the ionosphere in its vibrational frequency. enjoy. It's pretty normal. It's not bunker worthy. Definitely not bunker worthy. Oh, but the magnetic poles are going to flip. Are they? When? In thousands of years? They're just as likely to snap back to the geographic poles as they are to flip. So, also not scary. Oh, the pole flip. Not bunker-worthy material. The alarmism about it is not bunker-worthy. Yes. The religious-like fervor of people who have an absolute boner over the polar excursion, which isn't strong enough to be considered a polar excursion, but it's very spooky. From a geologic perspective, it's not a polar excursion. So, anyway, there's the ionosphere, the total electron content, and the usable frequency. And, yeah, did you know, folks, that you can be elite without being an elitist? We encourage it. You can totally be elite. You can just go out and do a thing, and you don't even have to be an elitist. You can be elite and not an elitist. Isn't that an amazing idea? Wow. Cheers. Again, seriously. Be elite. Anything worth doing is worth doing at a world-class level, no? So yeah, sunspots look like they've degraded since yesterday. They're looking weak. That one up there is still there, though, and that one doesn't have a name yet. So, I don't know. That's the one to keep an eye on. And when I say eye on, well, the pun was intentional. Here comes meteorology. And look at this. Oh, my God. Look at how close to the equator this UV band is. Like that UV right there. Like, you see how it's all, like, almost perfectly centered on the equator? That's called spring for the northern hemisphere. Or it's, the equinox time is when that looks like that. So I just figured I'd show it as we're less than a week from surviving another winter. Oh, no, winter. I'm spooked. Each season you should be spooked of, folks. Make sure you're spooked of spring. We'll find something to be spooked of in spring. What can we find? I don't know. Skunk weeds are going to grow in your backyard. Ooh, get in the bunker. Get in the bunker before you smell the skunker. All right, so anyway, here come our weather forecasts and so on. Surface winds of the east and the jet streams. Jet streams are the one weather pattern that I would view. If I could view only one weather pattern, I would use the jet stream. If I could look at only one piece of data and I had to know like global weather stuff, I would use the jet stream. It's splentacular. Surface winds. And once again, back to the jet stream, which is pretty jacked up. We got a tripled up jet stream over the eastern Pacific, which is yet another reason to get in your bunker. And remember, folks, social media is as social as chaining yourself to the wall in the basement with only canned peas and cheap vodka. Don't do it. It's a terrible idea. Anyway, like I said, less than a week till spring. The March equinox is coming. It's coming. Tuesday, March 19th at 11:06 p.m. Satellite imagery's next. And, I know, NASA projects that onto a fake spherical template in order to make it appear like a sphere, right? Yes, I know. All satellites are balloons and made of foam, right? Gotcha. Flat Earth for the lose. All right, and so we've got a bunch of mixed precip, a mixed bag. Yowzers. There's rain. There's snow. There are cultists. There are cultists everywhere. Folks, why does that map have so many cultists on it? Can anybody tell me? Let us know in the comments why there are so freaking many cultists. Are there more cultists in 2024 than have ever existed on the planet? Let me know in the comments. This is where I'm going to rant from now on. I'm going to save all the rants for the Earth weather section. Why are there so many cultists? Check out the severe weather forecast for the Midwest here, folks. Texas, Oklahoma, Missouri, Arkansas, Illinois, Indiana, and Ohio all showing massive potential for tornadic activity. Shout out to Reed Timmer. Follow Reed Timmer for some fantastic stuff over on Twitter. But don't follow us. Don't follow us. Facts are very, very dangerous. So do not ever go to x.com/smashomash and press follow, because that would be very dangerous. We would cite a lot of facts, and you may be poisoned by those violent, violent facts. Next, forecasts. GFS 72-hour. Pressure and precipitation is first. Total accumulated precip is second. Some heavy rains coming to Texas. Also some Gulf states there will be engulfed in drenching moisture. Snow forecast is next. And all the hot air in Colorado is not going to prevent a bunch of snow there. Some heavy snows there coming to some isolated regions of like 3 feet. Dag! Next, temperature anomaly forecast in degrees Celsius. The same model. It's the GFS. And the warm weather's going to blow out soon. So, well, I hope you got outside while it was here. It's still wintertime, folks. And, ooh la la, the forecast for Lehigh Valley today was 76 degrees Fahrenheit. Not half bad. Not half bad. It's enough to make you want to support your local bike shop, right? Support your local bike shop. Like, if you don't like this one, I don't care. Support your local bike shop. You know, pay the people who know how to build these things to build these things. I don't know what makes them go. I prefer to build riders. I just, it's something with the legs or something. I don't know how it works. It's magic. Anyway, lightning's next. And dag, check it out. We had some pretty bonkers lightning stretching all the way from Lake Michigan down to Oklahoma. Do we have any current strikes? I'll bet we do. Severe forecast in effect. Possibly damaging winds and hail associated with some of these cells. And if you want to know where in the hail the worst cell is, right there it is. That is a bonkers thunderstorm there, right by Mountain Home. Whatever state that is. That's, to quote stuttering John Menendez, it's Arkansas. That's what it is. Dag, that's right by the Ozarks. Check it out. It's the Lake of the Ozarks, folk. Dear God. Oh, my God. That is... Seriously, though, folks, use lightningmaps.org next time you hear thunder. It is berserk. Look at all the lightning. Dag. Also right by St. Louis. Some heavy thunderstorms there. Thunder rolling in all around. Yowzers. That is not a place to be riding a steel bike right now, folks. Or a carbon bike. Or an aluminum bike. Definitely not a scandium bike, because scandium bikes are just dumb. Scandium? Dude, I got this scandium frame. Scandium? What about magnesium? All right. Anyway, we got to close this thing out. This video is way too long. And there's a U.S. Doppler radar map. Here's the lower 48, which features like 100 million cultists. 100 million cultists right there. I'm just kidding, folks. I'm sure it's not that many cultists, but there are a lot of cultists. Dear God. That's better. All right, so yeah, there's the satellite imagery. There is the water vapor map, and look at that moisture making its way toward the mid-Atlantic states. Indiana and Ohio are in the crosshairs. Here's your recap. The Great Lakes states are going to get hit as well. Strong line of storms there across especially Illinois, Missouri, and Arkansas. Making their way out of Oklahoma as we record. There's a satellite view. Some strong cells popping up. You want to take a closer look? It's a perfect time to do it. Let's take a little closer look here. That should be some bonkers cells. All right, let me switch to animation. Here we go. Now you're getting a tutorial. There you go. Here's what's going on. That is what relatively super cells look like. They flatten out like pancakes because they can only get so high in the sky before they have to start spreading out, and that's exactly what they do right there. Anyway, there's the water vapor map to close this thing out, and here's me out of here. See you next time. In the meantime, may that solar wind be at your back. I'm going back to the bunker. Whoa!